Okay, dear students, in the today's class we'll discuss about that objective for alcohols, phenols, ethers chapter, organic chemistry, second chapter, that is alcohols, phenols, ethers. Okay, let's see that first question is related to isomerism. We know very well the general formula of alcohols and phenols same. General molecular formula, because alcohols are the functional group isomers with ethers. Let's see the first one. Alcohols and ethers. Alcohols and ethers are functional group isomers. Functional group isomers. Okay, what is the meaning for functional group isomerism or functional group isomers? The compounds having same molecular formula but different functional groups are present. See, in alcohols, the functional group is OH. And in ethers, the functional group is O. The oxygen atom is connected with two alkyl groups. Is known as ethers. Okay, now which of the following pairs compounds are the functional group isomers with each other? Let's see the first one. This is alcohol. This is a primary alcohol. The first one, and it is secondary alcohol. The primary and secondary alcohols means the OH position is changed. That's why those are not functional group isomers. Just those are positional isomers only. Those are positional isomers only. Total 3 carbon atoms are present here also. 3 carbon atoms are present. The OH position is changed. OH position is changed. That's why these are the positional isomers. Positional isomers only. Okay, not functional group isomers. Okay, students, understood? Now let's see the second one is also, this is primary alcohol and it is this is also one kind of primary alcohols only. Next, this is alcohol, the OH and Cl. Those are not isomers because not isomers. Because both molecular formulas are different. Both molecular formulas are different. Okay, students. Now let's see the fourth one is correct answer. Butane, 1-ol, and this is methoxyethane. This is alcohol and ethers. So same molecular formula. And one is alcohol, the second one is ether. So that's why these are functional group isomers, FGI, functional group isomers. So the answer is fourth option is correct. Okay, students. Now let's see that second question. Among the following, which is a primary alcoholic group? Okay, it's very easy, just fundamental only. What is the meaning for primary alcohols? If OH group is connected to primary carbon, those are called primary alcohols. Primary alcohols general representation is being like this: CH3 bond CH2 bond CH2 bond OH. Like this OH group is connected to primary carbon. Those are called primary alcohols. So the answer is first option. Let's see here the second option. This carbon OH group attached carbon is connected with 3 carbon atoms. That's why it is a tertiary carbon. That's why the OH group is attached to tertiary carbon, means it is tertiary alcohol. Tertiary alcohol. Now here let's see the OH group is attached to secondary carbon. That's why it is a secondary alcohol. Now the fourth one is C double bond O group is present, means it is ketone functional group. It is a ketone, carbonyl compound, ketone. So the first option is correct. It represents the primary alcoholic group. Okay, students. Next, let's see the third question. Among the following, ethyl alcohol is contaminated with 9.5 percentage methanol and 0.5 percentage pyridine is known as a denatured spirit. Is known as a denatured spirit. So only 95 percentage ethyl alcohol. 95 percentage ethyl alcohol is known as rectified spirit. Rectified spirit. Okay, students, rectified spirit. See here, 90 percentage ethyl alcohol C2H5OH plus the remaining 9.5 or 9 percentage methanol and 5% 0.5 percentage pyridine is known as denatured spirit. Is known as a denatured spirit. Denatured spirit is unfit for drinking. It is a unfit for drinking. Unfit for drinking. If anybody are drinking this denatured spirit, means what happens, ma? They lost eyesight, and sometimes they will die also. If they took more quantity, they will be die. Otherwise, they lost their eyesight. So that's why this industrial spirit or denatured spirit is unfit for drinking. Okay, so it contains 90 percentage alcohol, ethyl alcohol, and 9.5 percentage methanol and 0.5 percentage pyridine and copper sulfate also they are adding. So it is called as denatured spirit. Is very important. This direct composition only important. Now breaking of a big organic molecules into small in the presence of enzymes. In the presence of enzymes, the breaking of big organic molecules, the polymers like a starch in the presence of diastase enzyme is converted into maltose. The maltose in the presence of maltase enzyme is converted into glucose and fructose. The glucose and fructose in the presence of zymase enzyme is converted into ethyl alcohol. Is known as a fermentation process. Is known as a fermentation process. Okay, students, let's see that the fourth question. Starch fermentation process. Starch means C6 H10O5 N times. It is a polymer. It is a big molecule. The starch upon hydrolysis in the presence of diastase enzyme. The presence of diastase enzyme is converted into maltose C12H22O11. Okay, this is maltose. This maltose C12H22O11. This maltose upon hydrolysis in the presence of maltase enzyme gives C6H12O6 and C6H12O6. Okay, now this C6H12O6 produce glucose. This is nothing but glucose. This C6H12O6 upon oxidation in the presence of zymase enzyme is converted into ethyl alcohol plus carbon dioxide 2CO2. So this method is known as a fermentation process. Starch is a big molecule or polymer. Finally is in the presence of enzymes is converted into ethyl alcohol, small molecules. That method is known as a fermentation process. Okay, students. Let's go for next question. Which alcohol is most reactive towards HCl and ZnCl2? HCl and ZnCl2. See, this is the fifth one is Lucas reagent. Alcohols ROH the reacts with HCl in the presence of ZnCl2 is known as Lucas catalyst, Lucas reagent. Lucas reagent, then the CO bond will cleavage. This is CO bond cleavage reaction. Bond cleavage of alcohols. Okay, the product is RCl plus H2O. Okay, alkyl chlorides will form. So in this alcohols reactivity for CO bond cleavage. CO bond cleavage. Carbon and oxygen, in between the carbon and oxygen bond cleavage. See, for this always tertiary alcohols are more reactive than secondary alcohols and then primary alcohols. That's why this Lucas reagent is used for the identification of primary, secondary and tertiary alcohols. Tertiary alcohols forms turbidity immediately when compared to secondary alcohols takes 5 minutes time and primary alcohols takes a lot of time. Upon heating at high temperature, primary alcohols forms turbidity slowly. That is also. So that's why the fifth question, which will react very fast, tertiary is fast. The reverse in alcohols ROH. The OH bond cleavage. O bond H cleavage reactivity order. Reactivity. See, generally in this O bond H cleavage is nothing but it explains that acidic nature of alcohols. In that primary alcohols are more reactive than secondary and then tertiary. Tertiary alcohols are very less reactive for the cleavage of OH bond. For the cleavage of CO bond, tertiary is more. Okay. So in esterification reaction, what happens, ma? In esterification reaction in alcohols, the OH bond will cleavage. That's why primary alcohols are more reactive in esterification when compared that secondary and then tertiary alcohols. Okay. Next, sixth question. Let's see isopropyl alcohol on oxidation. First, what is isopropyl alcohol? Write its molecular formula. Isopropyl alcohol. This is iso group. Okay, at one end, two methyl groups are connected with CH bond. That is known as iso group. Iso total carbons are 3 only. Isopropyl alcohol. This isopropyl alcohol is a common name. Its IUPAC name is propane. Propane 2-ol. Propane 2-ol is upon oxidation is nothing but secondary alcohols. Secondary alcohols upon oxidation to produce ketones. CH3, C double bond O, CH3. Okay, ma. So that product is acetone. This, what is the name of this? Acetone. Primary alcohols upon oxidation with strong oxidizing agent produce carboxylic acids. Mild oxidizing agents converted into aldehydes. What are the important mild oxidizing agents? PCC or PDC, MnO2, and another important mild oxidizing agent is CAN. CAN means cetic ammonium acetate. Cetic ammonium acetate is also mild oxidizing agent. So these mild oxidizing agents are present. Then that primary alcohols converted into aldehydes, secondary alcohols converted into ketones. Okay, secondary alcohols either mild oxidizing agent or strong oxidizing agent converted into ketones only. But the difference where it is coming with respect to primary alcohols only. Okay, that type of questions also are coming in further questions. Okay, for sixth question, isopropyl alcohol is secondary alcohol on oxidation produce propanone or its common name is acetone. So the answer is second option. Okay, let's see for next question. Seventh question. When tertiary butyl alcohol is passed over, tertiary butyl alcohol reacts with copper metal means I'll explain you one by one. CH3 CH2 OH, ethyl alcohol or primary alcohol. Or CH2 OH. This is primary alcohol. Okay, this primary alcohol is treated with copper metal at 300 degrees centigrade. Upon oxidation, loss of H2 converted into aldehydes. At the same way, secondary alcohols. The secondary alcohol treated with copper metal upon heating at 300 degrees, loss of H2 converted into ketones. Because here this hydrogen, active hydrogens are present at OH group attached to carbon. Now the loss of H2, this and two hydrogen atoms will loss in the form of H2. Then primary alcohols convert into aldehydes and secondary alcohols are converted into ketones. But what about the tertiary alcohols? Tertiary alcohols undergoes dehydration, loss of water molecule, convert into alkenes. CH3 bond COH bond CH3. Here hydrogen I will write separately and here CH3. Now here the at tertiary carbon, no hydrogens. It is tertiary alcohol. That's why it undergoes dehydration reaction. Dehydration to produce alkene. Alkenes will form. So when the tertiary butyl alcohol is passed over the copper metal at 300 degrees centigrade, what type of reaction will take place It's not oxidation. The first one, primary and secondary, are oxidation, but tertiary is a dehydration, loss of water molecule, convert into alkenes. So the answer is third option. Now ethyl alcohol reacts with bromine in the presence of red phosphorus. What is the product? Already in the alkyl halides and aryl halides, that chapter only we have discussed this 8th question. Ethyl alcohol CH3 CH2 OH, it is a reacts with red phosphorus. Bromine in the presence of red phosphorus is nothing but it produces PbR3 and the product is C2H5Br. Ethyl bromide is the product. Okay, so the fourth option is correct. Okay students, let's go for next questions. Okay, ethyl alcohol undergoes additions with some salts. This is important directly we have to remember that numericals. Addition reactions of ethyl alcohol. Okay, when they reacts with salts, anhydride salts, how many anhydride salts it will be adds? Ethyl alcohol C2H5OH. Ethyl alcohol is adding 3 moles of calcium chloride CaCl2. So that X is equal to 3, the first one. Now the ethyl alcohol is adding with magnesium chloride. How many magnesium chlorides will be added to 1 mole of ethyl alcohol? 6. C2H5OH 6 MgCl2. So the Y is equals to 6. And in the copper sulfate is present, then it will how many moles of copper sulfate will be added to 1 mole of ethyl alcohol? 3. C2H5OH 3 moles of CuSO4. So the Z is equals to 3. So the answer is 363, means second option is correct. Okay students, now let's see the 10th question. Which of the following on oxidation gives ketones? It is primary alcohol. First one is 10th one. Let's see, it is primary alcohol. Primary alcohols upon oxidation produce mild oxidizing agent. You have to use mild only. Either strong means acid. Mild to produce CH3, CH2, CH2. Sorry, 3 carbon atoms are there and 3 carbons containing aldehyde will forms. C double bond O H. This is aldehyde. The same way, this is ethyl alcohol is also primary alcohol. It's produced to CH3CHO, acetaldehyde. And this is butanol or butane 1-mole. It is also primary alcohol and it is produced to 1, 2, 3, fourth carbon. That OH, primary OH group attached, primary alcohol attached carbon becomes aldehyde. Now it is secondary alcohol. It is a secondary alcohol. It is converted into ketones. So which of the following? Which of the following on oxidation gives ketones? See here, printing mistake. The OH, one more OH gave. It's not a OH. It becomes CH3 or a hydrogen. This is upon oxidation to produce CH3, C double bond O, CH3. So fourth option is correct. So whenever the alcohol, secondary alcohol is present upon oxidation to gives ketones. Primary alcohols upon oxidation in the presence of mild oxidizing agent, aldehyde. Strong oxidizing agent, carboxylic acid. That is very, very important. Okay. Next. Let's see 11th question. It's very easy question. A reacts with sodium metal. A reacts with sodium metal and forms one product, that is B. Okay students, and same way the A also reacts with PCl5, forms C, and B and C combine. B and C combine to forms dimethyl ether. CH3 bond O bond CH3. This dimethyl ether means it is Williamson ether synthesis. Williamson ether synthesis. See, if sodium metal is present means it is a one carbon. Here one carbon and it is also one carbon. Means one carbon containing sodium methoxide CH3ONA and one carbon containing alkyl halides means CH3Cl. So automatically the A is CH3OH methanol because one carbon is present. Here one carbon is present. Automatically this is also sodium methoxide CH3OH. Okay, so the A is methanol and B is sodium methoxide and C is methyl chloride. Methanol, sodium methoxide and methyl chloride. Third option is correct. Okay, it's very, very important this kind of conversions. Next, see 12th question. Two organic compounds A and B reacts with sodium metals and releases hydrogen gas. Okay, two compounds A and B, they forms A and B react with each other to gives ester. What is that? Ethyl acetate. CH3, C double bond O, bond O, C2H5. Ethyl acetate is forming. Then what are the A and B? They are asked. What are the A and B? A is one is acid, second one is alcohol. This A reacts with sodium metal and this is also reacts with sodium metal and liberates hydrogen gas, and this is also liberates hydrogen gas. So let you have to take this is CH3COOH carboxylic acid, and this is CH3CH2OH ethyl alcohol. Alcohols reacts with sodium metal and liberates hydrogen gas. Carboxylic acid reacts with sodium metal and liberates hydrogen gas. But carboxylic acids are more acidic. Okay, the product is CH3COONA. Okay, plus half H2. Here C2H5ONA plus half H2 gas it will release, sodium ethoxide. Okay, these alcohols, this in acids, OH bond will cleavage for esterification reaction. In alcohols, CO bond will cleavage. Then loss of water molecule to produce esters. So the answer is acetic acid and ethyl alcohol. First option is correct. Okay, students. Okay, let's go for next question. 13th question. Which one of the following reagent is used for the conversion of 1 butanol into 1 bromo butanol into 1 bromo butane? 1, 2, 3, 4. This is a OH. 1 butanol into 1, 2, 3, 4. 1 bromo butane. Means what is the reagent? We have to use PBr3, phosphorus tribromide. Okay, students. So fourth option is correct. Now 14th question. Let's see. The 14th question, which of the following is the starting material for Grignard reagent for the synthesis of tertiary butanol? For the synthesis of tertiary butanol. Okay. So the final product is CH3OH bond CH3 bond CH3. Tertiary butanol. OH whole tertiary butanol means generally ketones reacts with Grignard reagent RMGX gives tertiary alcohols. Aldehydes with Grignard reagent RMGX produce secondary alcohols only. Okay, but it is a tertiary butanol, tertiary alcohol. So the ketone is acetone, CH3, C double bond O, CH3. Acetone reacts with methyl magnesium bromide, CH3 MgBr, followed by hydrolysis. Then we are producing tertiary butanol. So one is methyl magnesium bromide reacts with acetone. First option is correct. Okay, next one. Ethanol reacts with PCl5, gives A, and POCl. Another product is POCl3 and HCl. The A also reacts with silver nitrate. What is the major product they are asked? Okay, students, it's very, very important. Ethanol, CH3, CH2OH reacts with PCl5. The products are C2H5Cl, ethyl chloride plus POCl3 plus HCl. Okay, ethanol reacts with PCl5 gives A. Okay, ethyl chloride. Now this A reacts with A means CH3. This is A. Ethyl chloride is the product. CH3 bond CH2 bond Cl. This ethyl chloride reacts with silver nitrate AgNO2. It is a covalent nature. Okay, covalent nature. Then the nucleophile is nitrate ion NO2 minus. The product is The product is CH3 CH2 bond NO2 is major product. Okay, students. And in the same way, this ethyl chloride treated with potassium nitrate, it has more ionic, so that nucleophile is nitrile ion ONO. Oxygen is a nucleophile. Then the product is CH3 bond CH2 ONO is major product. Okay, students, but actually here options are not there. A is ethyl chloride, it is very clear, but not ONO, it's silver nitrate, NO2, that is the correct option. Okay, silver nitrate, AgNO2, then they forms nitroethane, but okay, reacts with potassium nitrate, forms ethyl nitrile, C2H5ONO. Okay, the same way KCN forms cyanides, AgCN forms isocyanides. Here AgNO2 forms NO2, nitro compounds will forms, KNO2 forms nitriles will forms. So these observations are very important. Nucleophilic substitution reactions of alkyl halides. Okay, this alkyl halide, how it is formed from alcohol. These conversions are very important. Okay, let's see that 16th question. Among the following, the reactivity order with sodium or potassium metals. Sodium or potassium metals means already before only I said it is nothing but the cleavage of OH bond. Sorry, CO bond. See, OH bond cleavage, not CO. OH cleavage, they reacts with sodium metal, forms RONA plus half H2 hydrogen gas, it will be liberates. Okay, the reactivity of alcohols, primary is more than secondary and then tertiary. So the first option is correct. Now the reactivity order of dehydration of alcohol. Dehydration means loss of water molecule. It is nothing but the cleavage of CO bond. The cleavage of CO bond in which the reactivity order is tertiary is more than secondary and then primary. Okay, the 17th question. The dehydration reactions of alcohols is nothing but the cleavage of a CO bond. Means they form stable carbocation. Tertiary alcohols forms more stable carbocation. That's why the tertiary alcohols are highly reactive. So fourth option is correct. Now the dehydration of butane 1-mole gives the major product. Okay, let's see that CH3 bond CH2 bond CH2 bond CH2OH on heating in acidic medium, upon heating, loss of water molecule, it produces two products. Here the OH is attached to primary carbon. Now first it will forms one intermediate CH3 CH2 bond CH2 bond CH2 plus primary carbocation is unstable. Okay, then it is rearranged to gives CH3 CH2 bond CH bond CH3. Okay, if you have here two beta hydrogens, alpha beta carbons are present, this is beta and this is also beta. So here if hydrogen is removed at beta and this side CH3 hydrogen is removed, then produce two products. One is butene and another one is but1-ene. So this is more substitute alkene is the major product. This is a minor product according to Sage of rule. So the major product is but2-ene. But2-ene is the major product. Okay, students. So primary alcohol, it is butane 1-mole on dehydration, loss of water molecule, convert into alkenes. So actually primary carbocation is present. This is unstable and hydrogen will be shifted. This hydrogen will be shifting takes place at this secondary hydrogen to primary carbocation, then forms more stable secondary carbocation intermediate. Then it is stable. Okay, students. So it contains right side and left side two beta carbons are present. The inside left side beta carbon is secondary beta carbon. From hydrogen are removed means where product is but2ene. It is more substitute alkene. It is major. Okay. So the answer is second. Now let's see the 19th question. 19th question. The correct reactivity order of alcohols in esterification reaction. In esterification reactions, alcohols, in alcohols, OH bond will cleavage. The OH bond reactivity, what I said, my dear students, primary is more than secondary.